Hi everyone, this video is going to look at equations of lines in the form y equals mx plus b, y equals b, and x equals a. So the learning goals for this video are to understand the geometric significance of those characters m and b in that equation, y equals mx plus b, and then also to determine the equation of a line given its graph. So let's start with a situation from a real world context. So an equation relating cost versus time renting a scooter is C is equal to 15t plus 30. How do we graph this relationship? So this is a review of what we've done before. So remember that this is the initial value, and the 15 here, that's the rate of change. So that will be the cost of renting a scooter, or the charge for renting a scooter per hour. So, but it starts at 30. So I'm going to put a dot here at 30. And this is going to go up by $15 every time. So, so after 1 hour, it's going to go up 10 and then 15. And then after another hour, it's going to go up by 10 and then 15. Another hour, 15, and then another hour, 15. So we have a graph that kind of looks like this. Let's make it green. Why not? So that's what our graph would look like. So we can connect the equation of a line with a graph on the line. So we can also go the other way around too. So that's sort of the goal for today. We're going to be looking at equations instead of with C's and T's and D's and stuff like that. We're going to be really just focusing on our Cartesian plane with X's and Y's. We're going to use technology right now just to graph a relationship between X and Y using that equation. So we're going to use y equals mx plus b. And I'm going to show you what happens to what the graph looks like when we change m and b around. So here we have a graph where, and I just typed in y equals mx plus b on the Desmos calculator here, and created some sliders here. So right now, m is at 1 and b is at 0. So let's just take a look at what happens when we move m around. So if I'm going to make that larger, look what happens. This graph gets steeper and steeper. Now I'm going to move this graph back, or sorry, move m back to 1, and then let's look what happens when I make it 0. Right? When it's 0, it's a flat line. Now when the slope, or sorry, when m is negative, look what happens, right? So now this has a negative slope because it's going downwards, and the more negative, the steeper it is. So this m here, this number really is just controlling the slope of this line. Now let's look what happens when I change b though. So I'm going to move this to let's say -5. Whoops, -5. Now the thing that I notice about -5 is, look over here. This is the y-axis. So where the line crosses the y-axis is called the y-intercept. And it's at 0 and -5. Let's look what happens when I move this to -2. You notice that the y-intercept is at -2. Let's move this positive. Let's move it up to 3. You notice now the y-intercept is at 3. So this number b, that number at the end, indicates the y-intercept, where this line crosses the y-axis. So again, this number m, controls the steepness of the line, the direction, right? If the number is positive, then it's going upwards. If m is negative, it's going downwards. And the larger the number, the steeper the line. And again, b controls where this line crosses the y-axis. So those are some very important characteristics linking m and b to the direction and steepness of this line. So m, okay, whoops, let's back that up. So m is the slope. Okay, that's the slope of the line. Now, if it's a positive value, then the graph goes upwards. And if the value is negative, then the graph goes downwards. This value here, b, that part here controls the y-intercept. So in this case here, when I look at the y-intercept, it is at 3. So this is at 0 and 3. Let's look at the slope of this line. Use a different color. The slope of the line, if I find two convenient points, and if I do rise over run, right, the rise and the run, I notice that this is a rise of 1 and a run of 2. So m here is, it's rise over run, so it's 1 over 2. Now, because I know what m is and I know what b is, the y-intercept, I can create an equation. So y is equal to, instead of writing m, I know the slope. That goes here, 1/2 x plus the y-intercept, which is at 3. So that's what this, that's what the equation would look like to represent this graph. So our goal for today is to link graphs with equations. Now, let's look what happens when we have equations that look like y is equal to some number and x is equal to some number. So I'm going to go back to Desmos. So here we have Desmos, and I've inputted y is equal to b here, and I have a slider here that controls the value of b. So if I make b larger, look what happens. Right? This is, first of all, it's a horizontal line only, and the larger the number, the higher up it is. But let's just be very clear about the connection here. When b is 4, notice where the y-intercept is. It is at 4. And every value of y along any of these points along this graph is at 4. If I move this to 2, let's say, then the y-intercept is at 2. And of course, every single point on this line has a value where the y number is 2. So that's the relationship between the value of b and where this line goes. Now, let's look at what a graph of x is equal to a would look like. So I'm going to highlight that. You notice that right away it pops up a vertical line. So a right now is at 1. So I'm going to focus on the x-intercept here, which is where this line crosses the x-axis. So you notice it crosses it at 1. Now if I move this over, let's say I move it to 3, look what happens now. The x-intercept is at 3. If I move this to -2, then the x-intercept is at -2. So again, the value of this a has a direct relationship to the x-intercept of this vertical line. So let's go back here. So for a graph of y is equal to b, so we'll describe that. So for a graph of y is equal to b, it is a horizontal line. And the y-intercept is equal to whatever that number b is. Okay. So in this case here, this is a horizontal line, and it crosses at 3. So that means that I can write this equation of this line as y is equal to 3. I just need to know where it crosses the y-axis. Okay. For a graph of x is equal to a, this is an example of a vertical line. And the x-intercept is equal to whatever the value of a is. So in this case here, we notice that this is the vertical line, and it crosses the x-axis at -2. So that means to write an equation for this, I would write x is equal to -2. All right, we're just going to go through some more examples on how to determine equations of lines given the graph. So let's determine the equation to represent the given line. So remember, for any kind of a slanted line, we're going to use the equation y is equal to mx plus b, where b is the y-intercept and m is the slope. So that's the slope. All right, so we need to find those two things. The y-intercept is where this line crosses the y-axis. So it crosses it right here. It's at -2. And the slope I can calculate by finding 2 points. So I can pick this point. This is at 0 and -2. And I can find another point. Let's use this one here. This is at 2, 4. All right, so the slope, which is m, is equal to, remember we subtract the y values. So I'm going to do, it doesn't really matter, let's do 4 take away -2 divided by, and then I do 2 take away 0 because I subtract the x numbers. All right, so 4 take away -2 is 6, divided by 2 take away 0, which is 2. So m here is equal to 6 divided by 2, which is 3. Okay. Remember also another way that you can calculate the slope of a line is to do the rise over run. So if I had these 2 points, I notice that the rise would be 1, 2, 3, 4, 5, 6, and the run is 1, 2. So it would be 6 divided by 2, right? Rise over run. All right, now that I have the slope and I have the y-intercept, I write my equation that looks like this. Y is equal to, m's the slope, which is 3, x, and then the y-intercept is -2, so I write -2. So this equation represents this line. Let's look at another one. So we need, from y equals mx plus b, the y-intercept and the slope. So here's the y-intercept. The y-intercept is at it's at 1. Right? So this I know is going to be 1. Let's look at the slope. So let's pick 2 points. I already have one here. It's 0, 1. Let's pick another point here. This is at 2 and -3. So let's calculate the slope here. M is equal to, now I subtract the y numbers first, so I can do 1 take away -3. 1 take away -3 divided by 0 take away 2. The order is important. All right, 1 take away -3 is 4, divided by 0 take away 2 is -2. 4 divided by -2 is -2. And I know that I should have a negative slope because this line is going downwards, right? So I know the slope and the y-intercept, so I can come up with an equation. Y is equal to, m means slope, so that's -2x, and this is at +1, or the y-intercept is at +1, so I write +1. So again, this equation represents this line. All right, let's look at some special cases here. Remember, notice we got a flat line, so I know this is going to be in the form y is equal to b. Now, b is where this line crosses the y-axis, so it crosses it here at -2. So all I need to write here is y is equal to -2. All right, so again, a special case when the line is horizontal, it's just y is equal to, and then it's -2. Just something I wanted to point out. Lines are usually y is equal to mx plus b, but remember that a line that's flat has no slope. So the slope of these lines are all 0. So when we have y is equal to 0 times x plus b, 0 times anything is 0. So that's why this becomes 0 plus b. Well, b plus 0 is just b. So that's why every flat line like this with a slope of 0 has this form. Okay? It's just basically y equals mx plus b, but the slope is equal to 0. All right, let's look at another special case here. We've got a vertical line. So from before, we know that all vertical lines have this form. X is equal to a. And a is where this line crosses the x-axis. So we notice it crosses it here at 4. So all I need to write here is x is equal to 4. And that's how we find an equation to represent a vertical line. So I'm going to ask you to try a couple questions now. So here's an here's the graph. I'd like you to pause the video and try to calculate try to determine the two things here, the y-intercept and the slope, and then put them together to create an equation of a line. So give that a try. Unpause the video when you're done. All right, let's take a look at this question. We have a y-intercept of 2. And let's look at the slope. So we can pick any 2 points. I already drew that one. So let's use 0, 2. And let's look at this point here. That is 3, 3. So the slope is, remember, now I subtract the y numbers. So that's 3 minus 2. And then on the bottom, for the run, I do 3 take away 0. So I subtract the x numbers. So 3 take away 0. So the slope is 1 over 3, or 1/3. Our equation then is going to be y is equal to 1/3 x plus 2. Because the 2 is where our y-intercept is. All right, you try this one. So we have a vertical line. It's a special form. So I'll leave you to pause the video and try this one. And when you're ready, just unpause. All right, let's find the equation of this line. So every vertical line has the form x is equal to a. Now I just need to know where this line crosses the x-axis. It crosses at -5. So that means all I need to write here is x is equal to -5, and that equation represents that line. So I hope now you can calculate the slope of lines and determine the equation of any line on a Cartesian plane. Thanks for watching.